Welcome back to Algebra 2, Chapter 6, Section 3. In this book, we've been talking about polynomials, and last time I just showed you how the exponent, the leading exponent, will determine the shape of the graph. But really, I didn't bother with the whole poly part of it. For it to be a polynomial, it really needs more than one term. But even if it just has one term, even if it's just y equals x to the third power, it will have those shapes. And so that was the main thing we were talking about last time, was how the shape of the graph corresponds to the leading coefficient and the degree. Okay, just a little bit more about that. So now we are going to add, subtract, and multiply polynomials. Division is a whole different beast. We'll get there later. Alright, so notice in your book they have ones that are done vertically and horizontally. I want you to do them all horizontally. It's just the way it's done. It's babyish to do it vertically. You need to do it horizontally. Now, what I do, as I do this, I gather up the terms, and we will sing and dance when we get there. And I circle them and mark them out. And I have a college professor near here who taught my son. He said to circle them and mark them out in different color of pens, and my son really liked that idea, and he got all the colors to do it. I don't bother with all that. It's too time consuming. I like to do it faster, so I'm going to show you my way. But if my way is not good enough for you, you can write each exponent that can be combined in a different color. I'll tell you what I mean. Alright, so we're going to add these. Now, first of all, these parentheses really are not necessary and mean nothing. So I'm going to take them away. Whoop, because it's adding. If it wasn't adding, these parentheses would be important. But since it's adding, really, it's all, we're just going to have to gather up our terms. This is our dance. Stowing away the time. Oh yeah, good dancing. Okay, so what we do is I go and find what is my biggest exponent, and it's to the third power. Then I look and I find everything that is to the third power and I circle it. And that's all of them. Now I do what it says. 3x to the third power plus 1x to the third power is 4x to the third power. I'm through with those and I'll mark them out. I do this every time, because if I don't, I will leave a term behind. And I think about the military, no man left behind. In math, we need no term left behind. Alright, so now the next one down is squared. So I circle it, I go find any other squareds, and now I combine them. 2x squared minus 10x squared is negative 8x squared. I'll mark them out, and now I go look for x's. Got one right there. So I just write him down. You get circled and marked out. And now next I have bare numbers. Minus 7 plus 8 is plus 1. And there is the answer. Now, if it is subtract, we have an extra step. We have to distribute that negative. So it's like multiplying this whole thing times a negative 1. So negative 1 times 2x cubed is negative 2x cubed. Negative 1 times 6x squared is negative 6x squared. Negative 1 times negative x, two negatives make a positive, is plus x. And negative 1 times 1 is negative 1. I got rid of my parentheses and I gather up my terms. I look for the biggest exponent, and it's to the third power again. I go circle any of them I got. And now I combine them. 8x cubed minus 2x cubed is 6x cubed. Mark them out. Now I do the squareds. I got a negative 3 and I got a negative 6, and that's all I got. So that's negative 9x squared. Squareds go away. Now I do x's. Minus 2x plus 1x is minus x. Those go away. And 9 minus 1 is 8. Those go away. Everything marked out. I know I didn't leave a term behind. Multiplying. Multiplying, we just do the distributive property. I always do the first one on top and the second one on bottom. I always write my one that has less terms first and my one with more terms later. If the book gives it to me the other way, first thing is I switch it. Because remember, if I miss a problem, it's not because I didn't understand the math, it's because I was disorganized. So I organize and I do these little memory things every time. Alright, so I'm going to do x times 3x squared. I don't like that pen. X times 3x squared is 3x to the third power. X times negative 2x is negative 2x squared. X times negative 4 is minus 4x. Now I'm going to go the other way. Negative 3 times 3x squared is negative 9x squared. Negative 3 times negative 2x is 2 negatives make a positive 6x. I only have one. And then negative 3 times negative 4 is positive 12. Now, I gather up my terms, and I only have one x to the third power. Mark that out. Go look for the squareds. There's one and there's one. So it's negative 11x squared. Mark those out. Now find the x's. Minus 4x and plus 6x. That's plus 2x. Mark those out. And then I have a 12 left at the end. Woo, that was messy. Okay, but what about if you have 3 of them? Well, what I do is I do 2, and then I do the other one. And I think I want to do these 2. I want to do these 2 at the end. So I'm going to bring down my x minus 1. Does it matter which 2 you do first? No, because 1 times 2 times 3 is the same thing as 3 times 2 times 1. Remember that? So now I'm going to do the distributive property. X times x is x squared. X times 3 is 3x. 4 times x is 4x. And 4 times 3 is 12. I got some terms I got to gather up, so I better sing. Gathered up your terms. So I'm going to bring down what I didn't mess with. And now I've got x squared plus 7x plus 12. And I do it again. I'll do each of these. So that's x to the third plus 7x squared plus 12x minus x squared minus 7x minus 12. Now I gather them up. I'm going to get rid of that for right now. So I have x to the third is the only one. The squareds, I've got 7x minus 1 is plus 6x squared, mark them out. 12x minus 7x is plus 5x, mark them out. And then minus 12 didn't have anybody to combine with. All right, so that's how it works. Now the last thing is, your book shows you the special patterns. You know that there's certain patterns that like when we learn difference between two squares. But the thing is when kids try to memorize those special patterns, they get them wrong and they get the problem wrong. I want you to read it, look at it, see if you understand it. Think about it a little bit, meditate on it, but then go on. As you keep doing algebra, for college algebra, pre-calculus, you're going to start memorizing the patterns naturally, and you won't mess up if you sit there and go, okay, I'm going to memorize this, I'm going to memorize this. Then you memorize it wrong, and you get it wrong. And you can always do it without the special patterns, so you don't really need them. They're unnecessary. I know there are math teachers who are aghast at what I just said, but it's true, and they know it. Math is great.